All right, let's talk about covalent bonding and polarity. All right, so first let's review covalent bonds. What happens to valence electrons in a covalent bond? Remember, the valence electrons are shared, okay? Covalent bonds can be polar, where the sharing is unequal, and the electrons are pulled closer to the atom that has a higher electronegativity. Okay, so we end up with partial charges. The atom that has a higher electronegativity pulls stronger and has a partial negative. The atom that has a lower electronegativity has a partial positive. Okay, so here's again a demonstration. The partial negative means the electrons are pulled closer, so that will have a partial negative charge. Partial negative, the atom that has a higher electronegativity pulls the electrons stronger. Covalent bonds can also be nonpolar. That means the electrons are shared equally. So often this is between atoms of the same element, like two hydrogens, two oxygens, two nitrogens. Here are some examples. When covalent bonds are nonpolar, the molecule is simply nonpolar. Easy peasy. All nonpolar bonds, nonpolar molecule. So hydrogen gas, H2, nonpolar bonds, nonpolar molecule. Easy peasy. When the bonds are polar, it's a little bit more complicated because the molecule can end up being polar or nonpolar. What? Okay, let's see. So how do you figure it out? You look for symmetry. With symmetry, a molecule that has polar bonds is going to be a nonpolar molecule. So let's see. So here we have polar, 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 polar bond, polar bond, polar bond, polar molecule. Nonpolar bond, nonpolar molecule, easy peasy. But now look here, this is a polar bond and a polar bond, but it's a nonpolar molecule. Why? Look at that beautiful symmetry. Here's another one, polar bond, polar bond, polar bond, polar bond, but it's a nonpolar molecule. So let's look a little deeper. Water has a polar covalent bond between oxygen and hydrogen. This is the shape of water when we draw the Lewis dot structure. It looks like this. This shape is called bent. It's literally bent, okay? And it does not have symmetry because there are two hydrogens on one side of the oxygen and nothing on the other side. What's on the other side are these just lone electron pairs, and that's what kind of is pushing the hydrogens over to make the shape. But these are polar bonds and the molecule is still polar. Now, methane has a non-polar covalent bond between carbon and hydrogen. And then the shape of this molecule, because carbon has four valence electrons, so four hydrogens are attached. This shape is called tetrahedral, and it's nonpolar. So four equally distributed nonpolar bonds gives me a nonpolar molecule. Now, when we look at carbon dioxide, between carbon and oxygen, it is a polar covalent bond. The electrons are pulled more strongly toward the oxygen. But in CO2, there is a polar covalent bond on this side and a polar covalent bond on this side. So they're pulling equally, so the molecule ends up being nonpolar. So what would this molecule be? Well, we can tell this is a polar bond, a polar bond, a polar bond. It would be nonpolar, equally distributed, okay, right? Equal spacing between these, equally distribution. So the molecule is nonpolar, even though the bonds are polar. All right, what about this one? I talked about this one already. Well, this is polar bond, polar bond. Is there equal distribution? No, it's not in a line. It's not linear. So this is a polar molecule. Polar bonds, polar molecule. What about this one? Well, this is a nonpolar bond between them. So nonpolar molecule is only just one bond. Well, a double bond, but between one set of atoms. What about this? Well, this is a polar bond, and it's a polar molecule. There's no symmetry. There's not something else on the other side of the fluorine that exactly matches. So the molecule is polar and the bond is polar. All right, what about this one? You can see this demonstration shows these are all polar bonds, but it's equally distributed because they're all chlorine, so it's nonpolar. Carbon dioxide, polar bond, but non-polar molecule because equal distribution, symmetry, one oxygen on this side and one oxygen on this side. What about this one? So this is a nonpolar bond, a nonpolar bond, a nonpolar bond, a polar bond. So this molecule would be polar because there's not equal distribution. It's not symmetry. And what about this one? This is NH4 positive. That's the ammonium ion. This one is going to be nonpolar because it has symmetry, 4 things around the nitrogen. If this hydrogen was not here, it would be polar, but because it is there, this is a nonpolar molecule. And that's covalent bonding and polarity. Remember, with symmetry, polar bonds can result in a nonpolar molecule.